Hi. So you're going to be using the packet that you picked up on Friday to take notes on 5.1. If you didn't get the packet, go back into eCampus and where it says blank notes, go ahead and you don't have to print out the whole packet, just print out the first 2 pages so that you can take notes on this. So let's first take a look at the rules of exponents. We're going to give the rules in general terms using variables a, b, m, and n. Now, m and n are going to be positive integers. And a and b are going to be real numbers. So when we have the product rule, we have the same base being raised to exponents. When we combine them, that we keep that base and we add the exponents. So x to the 7th times x to the 5th is going to be x to the 7th plus 5, or x to the 12th. 3 squared times 3 to the 4th is going to be 3 to the 2 plus 4, or 3 to the 6th. Now we can evaluate that and we get 729. The product to power, we have a product being raised to a power, and because it's in parentheses, it applies to the whole thing, so that m applies to each of those factors. So our xy in parentheses being squared is going to give us x squared y squared. And we can do the same thing with 4m being cubed. We get 4 cubed times m cubed. Now 4 cubed can be evaluated. That's 64m cubed. Our power to power, we have a base with a power, and that whole thing is being raised to another power. We're going to multiply those powers. So it's the base times the powers being multiplied. So x squared to the 4th is going to be x raised to the 2 times 4, or x to the 8th. 5 cubed raised to the square is going to be 5, 3 times 2, or 5 to the 6th. That can be evaluated. It's 15,625. We have a couple more rules. We've got the quotient rule, which if we have a base raised to an exponent divided by the same base raised to another exponent, we're going to subtract the exponents. So on the example, we have x raised to the 9th power divided by x to the 3rd power. We're going to just subtract those, and it becomes x to the 6th power. Same thing with this one, the 7 to the 5th, and we're going to subtract the 2, so we get 7 cubed. Now 7 cubed can be evaluated. That's 343. And then the quotient to power, just like the product to power, we're going to apply that power to both factors. So on our example, x divided by y raised to the 3rd power, we're going to get x cubed divided by y cubed. And on this one, we're going to have 6 squared divided by x squared. And you can evaluate the 6 squared to become 36 divided by x squared. So these rules can be put together. We're not going to just do one rule at a time because that would be way too simple. Let's take a look at the following. We've got this particular one. We've got 5x squared y cubed times 2x cubed y to the 4th. I'm going to take the 5 and multiply it by the 2, and that's going to give me 10. And the y squared times y cubed is going to be, or I'm sorry, x squared times x cubed is, you're going to add those, right? And the y cubed and y 4th, you're going to add those exponents, 3 and 4. So you're going to get 10x to the 5th, y to the 7th. I'm going to do the same sort of thing. 27 to this next example. 27 divided by 3 is 9. And 5n, that should be m. 5m divided by m. Keep in mind that these ones in the denominator have exponents of 1. So it's going to be m raised to the 5 minus 1, and n raised to the 3 minus 1. So that's going to give me 9m to the 4th n squared. And now it's your turn to try some. So take a look at these and see if you can work these out. To pause the video, work them out, and then turn it back on and see if you got them right. So there's your answers. Check and see if you got them right. I didn't show all the work. If you have some questions, when I come back, you can ask me, or you can ask your friends. See if you guys can figure it out together. Okay, so we're going to look at 0 and negative exponents, and a and b are still going to be our real numbers, and we're not going to let them be equal to 0 because otherwise that's a whole nother set of rules. So let's take a look at what they are if we have zeros. So a to any base raised to the 0 is 1. So x plus y is our base raised to the 0, it's 1. For x is our base, it's raised to the 0, it's 1. The other thing is if you have a negative exponent, that means reciprocal. So whatever has a negative exponent, if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So x to the negative 1 becomes 1 over x. 2 to the negative 3 becomes 1 over 2 cubed. And if I had 2 to the negative 2, I would make that 2 squared over 1, which would be 4. That's just another side note. So here's a few other examples. 5 to the 0, once again, it's 0 power, so it's going to be 1. 5x to the negative 3. Well, the negative 3 only applies to the x, so 5 stays in the numerator. We have to put a division bar there so that we can put x in the denominator raised to the 3rd power. Whew, now we're getting into some really fancy stuff here. We've got 16x cubed y negative 2, 25x squared y to the negative 6th. So I'm going to keep this, I'm going to put a division bar here. 16 over 25. You know what, I'm going to take that division bar out because I don't want it quite that long. Just going to make it 16 over 25. If I take x and I subtract, use the quotient rule, I'll do 3 minus 2. And y is going to be negative 2 minus negative 6. Well, 3 minus 2 is 1. So I'm going to have 16 25ths x to the 1st power. Negative 2 minus negative 6 is 4. So I'm going to have y to the 4th. I don't have any of the variables in the denominator. One more time for you to give your try. Try these problems, pause the video, do the work, and then come back and see how well you did. So you finished. Now go ahead and check your work. Pause the video so that you can look at each one of those. If you didn't get it quite right, try it again and see if you can figure out what went wrong and how to do it right this time. And see you later.